about it. So there we go. So hopefully you can see my screen as well, which should be useful. So that should be saying .NET Knots. So thank you very much for coming along to .NET Knots. Hello, folks. So before we get going, we have got a code of conduct in place. Those that have been before already know what this looks like. There's lots of words, but in the bottom right-hand corner, you'll see it says, be kind and considerate to others. And so long as everybody does that, then everything will be fine. But if somebody does feel like somebody is breaking the code of conduct, then either send myself or Connell, who's my co-host here, hello Connell, a message, and we'll endeavour to sort all of that out and keep you in the loop with that. So we'd like to thank our sponsors for tonight, us people that are in person. We're at the BGSS offices, who are a consultancy, fantastic consultancy based out of Nottingham, and they're very kindly sponsoring the alcoholic drinks that are here and also the location. So thanks to them. Rebel Recruiters are a really good recruitment company based in Nottingham as well, and they're sponsoring our in-person pizza tonight. So again, if you come in person, then you get pizza and beer, which is always nice. Onwards from that, JetBrains I'll talk about shortly, and my company PJG Creations, although I do work for another company as well. That's sponsoring all of the hosting and the organization. So JetBrains, if you're interested in JetBrains, they make developer tools for developers. So JetBrains Rider, IntelliJ, PHP Storm, WebStorm, all of those sorts of cool tools. If you'd like to be in with a chance of winning, I think I'm probably going to have at least 2 licenses to give away. So you've really got a good opportunity tonight. You can win a 12-month license to any one of their products. If you tweet on the hashtag .NET Knots tonight, then we'll draw out at a later date and get in touch with you and give you a code for you to claim that. So do make sure you tweet. I'm an MVP. I'm the only one here at the moment, but that's a Microsoft Most Valuable Professional. So if you're doing community events like this in and around the Microsoft space, or contributing to open source, or producing blogs, or anything like that, then you could be in with a chance of becoming a Microsoft MVP and working with Microsoft more closely. If you're interested in that, then by all means send me a message or look me up at Pete_codes on Twitter, and I can help you with that process. Tonight we've got Leng Dong talking about LLM Ops with Azure AI Studio and PromptFlow, so that's going to be great. Next month, although this is still to be confirmed, in theory we've got Laura Graham Brown talking about Microsoft Fabric, which should be an interesting one. We've got 2 June events due to the fact that it was bank holiday last weekend, so we move. And then later on this month in June, we've got Christoph Cremon talking about Azure IoT operations at Knots IoT. So it'll be good to get a Knots IoT back as well, because that's not been on since February. So yeah, and with that, it's time for our speaker. So we'll do the normal laptop switching over business, and we'll be with you any second. So thank you. And then we'll wait for Connell to make sure that you can hear Leng.
Can't hear anything at the moment.
No, make sure you've got the right audio device selected in your Zoom settings there. I'll say if you just, maximize that. So, little up arrow. There you go. That's why then. Right, how about that?
Hear me now?
Yes.
Yeah, quality's a bit fuzzy.
So the quality wasn't all that good, but you can speak up. I'm assuming you can hear me all right, Colin.
Yeah, again, but I think through Lens audio, and it's just like there's a lot of noise.
That's with the built-in microphone.
There you go, that's better.
Oh, okay.
Okay.
Perfect.
Yeah, maybe I just stand close to the laptop.
No, that's fine. I can hear you.
So shall I start?
Yeah, go ahead.
Okay. Okay. Hello, everyone. Welcome to LLM Ops with Azure AI and PromFlow. So I'm Long. I'm going to give some introduction about myself. I'm currently working as AI engineering consultant at Avanade. So Peter is my colleague. So we used to work on the same project earlier this year, and I got a PhD in computer science from Loughborough Uni. And before joining Avanade, I used to work as a data scientist at Eon Energy in the Nottingham City Centre. And my role was about training machine learning models to predict if the customer is able to pay their energy bill or not. I prefer Python over .NET for its versatility in all sort of AI libraries. And outside of work, I enjoy playing guitar and taking some casual walk with my dog. So the agenda for this talk, firstly, I'm going to talk about what is LLM Ops and why we need it. And then I'm going to walk through the features of the Azure AI Studio and PromFlow and how this thing can streamline the LLM Ops process. And I will give some customer success story and how we use to leverage those tools to deliver a proof of value project. Then I will dive into some hands-on demos. Then you have an idea of how those things set up in the Azure AI Studio and PromFlow. Okay, so AI is just everywhere. If 2023 marks a year, we see a lot of AI prototypes. So in 2024, we should see a lot of AI applications into the production. So there are some challenges around pushing Gen AI product into production. So first, it's difficult to get started because the technology is evolving very fast. Make it difficult to decide what model to use, what framework to adopt, and along with that, it's very hard to find the relevant and comprehensive documentation and guidance. So when you're into the development phase, the application often require multiple technologies. You need to orchestrate those technologies to make them work together. And also about context, the large language model doesn't necessarily know about your data. So the GPT model was trained based on the internet data a few years back. So if you want to let the GPT model answer a question about your data, you need to plug your data into the model. So there's a pattern called visual augmented generation. I will cover that later. Also, even when you create a Gen AI application, it's hard to figure out how you can evaluate this AI application. So which metric you can use and how you can use those metrics to optimize the use case. And finally, the operationalization. So there's always concern around privacy, security, and grounding. So currently, developer lack of experience and knowledge on how to evaluate, improve, and validate the solution. So now we introduce LLM Ops. So LLMOps is all about how to bring large model applications to production. So by definition, it's about bringing together people, process, and platform to automate the LLM-infused software delivery and provide continuous value to our users. So on the business side, it's about streamlining the process to ensure seamless AI implementation and to drive business outcomes. And on the IT side, it's about integrating large language models into practical applications and deliver robust AI-powered solutions. So if you came from some data science background, you may heard of the term MLOps. So MLOps is different from LLMOps. So for MLOps, it's about machine learning and operations. So it's about training the model. So the MLOps, the target audience are machine learning engineers and data scientists, and they work around the data that can be used to train the model, and they need to version control all the trained models and manage the Python environment that you can use to train the model. And to evaluate MLOps, the only metric you need to consider is accuracy. That's about how your model is able to predict the outcome. And also for machine learning models, you have to build the model from scratch using the training data. And for MLOps, it's more on the application side. So it's about how you deploy the pre-trained model into the software application. So here we require the AI engineer and app developer to work together. So that's set to share for the MLOps is large language models. The agent can perform specific tasks, plugins, the prompts, or chains of prompts. And in the end, normally the application will be deployed as an API endpoint. So in terms of evaluation, not only need to worry about the accuracy of the model, the GenAI application may also produce harmful content. And if you're doing retrieval augmented generation, you also need to measure the groundedness of your response to see if the GenAI response aligned with the retrieved information. And also you need to consider the costs associated with using large models. So GPT model can be very expensive. And also there's always a latency associated with using the larger models. So GPT-4 normally will be slower than GPT 3.5. And also you need to consider there's a token per minute rate limit on using those models. And for the models, all the models are pre-built, so you don't need to train the model again, but you can fine-tune it. And most of the time, the model just serves as API. That's a concept of model as service. Okay, so to operationalize LLM app development, normally you need to go through several phases for the whole development lifecycle. So in the initial design and the development phase, you need to develop a basic application that can fulfill certain business logic. And you can do some debugging and testing with a small set data. If you accomplish certain business goals, you can move into the evaluation phase. So during the evaluation, you can evaluate your GenAI applications against a larger data set and evaluate with the different metrics like quality, relevance, and safety. And in this phase, you can try different versions of the prompt and see which version works best. So if you're happy with the version of prompt that produces best outcomes, you can push this version of prompt into the production layer. So in the production, you can carry on monitoring your production workload and even collecting some feedback from the user. And also those collected data can go back to your development phase. You can start over another iteration to improve the quality of your GenAI applications. So apart from that, the customer also wants other things like private data access and controls and ability to do the prompt engineering. Also how we can integrate these things into the CI/CD pipelines. And all the prompt needs to be version controlled, and the result needs to be reproducible. And also very importantly, the safety and responsible AI something we have to consider. So to solve all those problems, Microsoft released a feature called Prompt Flow, along with their other AI features. So with Prompt Flow, you can consider it as a orchestrator for all the AI-related resources. So it has ability to manage connections. That means with Prompt Flow, you can develop and manage flows that connect to a variety of large language models, vector database, APIs, and prompt and Python tools. And also you're able to test your prompt flow with a large data set and score the application out in parallel. And then you can evaluate the quality of your GenAI applications with metrics like performance, groundedness, and accuracy. So on the prompt engineering side, you can easily tune the prompt with variants and versions, and you can share different version of prompt as asset across teams. So once you're happy with your LLM application, you can deploy the prompt flow as a managed endpoint with a few clicks buttons, or you can more flexibly, you can deploy the Docker container for rapid integration. So what is the coding experience for prompt flow? So first of all, you got a prompt flow. In prompt flow, everything can be versioned in YAML code. You can define your flow in the YAML format, which can stay aligned with the reference source files in the folder structure. And also you can transition your prompt flow between cloud and local. You can export your prompt flow from the AI Studio web portal and to a local environment for the version control and local debugging. And also you can import your flow code back to the cloud Azure AI Studio for further upstream evaluation and deployment. You're able to integrate your prompt flow via CI/CD pipeline. There is a prompt flow CLI or SDK. You can write bash script or PowerShell script to integrate into your CI/CD pipeline for delivery. And for local development, there is a VS Code extension you can use. So in the VS Code, you've got very similar experience as your online portal with a code editor, and you have a local connection management, and you can also run batch jobs in your local development environment. So once you have a GenAI application ready, you want to know how you can evaluate this application. So there's several metrics that can use in the Azure AI Studio automated evaluations. So when your GenAI produces a response, there are several reasons that the response may be not good. So first, the response may be wrong, so it doesn't reflect the ground truth. Or the response can be not relevant to the question from the user, or the user may simply it doesn't lack the language of the response. So there may be some issues with the fluency and coherence. So with that, we can use Azure AI Studio automated evaluations. We can use a user-provided test data set, and also we can use AI-assisted data set generator to produce a batch score file. So we can submit this batch scoring file to the prompt flow application, and we can receive a list of responses from the prompt flow. Then we apply all those AI Studio defined metrics to see if your flow works good or not. So in terms of development, there are several ways to deploy prompt flow. So the easiest way to deploy is use Azure AI Studio managed real-time endpoint. You can just deploy it as a built-in API endpoint with a few clicks button from the Azure AI Studio web portal. And user can just make API calls to this API endpoint. And also for some jobs, prompt flows that may require like prompt training. like in use cases, like you need to do the summarization and API extraction. So sometimes this flows takes long time to run. So in this case, you can implement flow as a batch job and with parallel processing capabilities. So you can implement that in Azure machine learning batch endpoint, Azure batch. So basically you just wrap up your pump flow as a Python function and you can run any Python script to call the pump flow. And the most flexible way to deploy pump flow is to use Docker container. There is a Docker build command in the pump flow CLI. You can just wrap up the pump flow as a Docker image, and you'll be able to deploy to any cloud resources like Azure function, web app, container instance, or even Kubernetes. So that's all the features about pump flow and AI Studio. So now I'll dive into a customer success story and how we use those tools to deliver a POC for our customer. So for this use case, we work for a UK government agent in the healthcare industry. So this agent, they need to do a thing called systematic review process, and they reach out to us and ask if we can use GenAI to optimize this systematic review process. So in this systematic review process, they need to hire a lot of people to examine a certain research questions. So the research question can be like around a certain disease or a health problem. Then they will hire 2 reviewers to extract at least maybe 100 articles from an online like academic paper database. So they download all those papers and they need to read through all those papers. And also they were given a list of eligibility criteria to decide if a certain paper need to be included in the systematic review. So I will just give example of how the eligibility criteria looks like. So there are some criteria like population. So you need to look into the paper. If this paper examine the human population of any age diagnosis with this certain disease, if they satisfy this criteria, this paper will be included in a systematic review. And also there's other criteria like countries. If the study is conducted in a high income country, or the publication type is a peer review studies, or if it's conference abstracts, this paper will be excluded from the systematic review. So for this proof of value practice, they want us to explore the potential to use GenAI to classify the paper based on the provided eligibility criteria and return an explanation for the decision. So basically, they want to use AI to replace one of the reviewers. So then they can use one reviewer and one AI to decide if the article should be included or excluded. So what we get from this client is a example topic of the systematic review and a list of 58 papers related to this topic. And also they provide the list of eligibility criteria we can use to tell AI to do the similar things. And also they provide us the human decision on if each of the articles should be included or excluded. So you can use this human decision to evaluate our model. So to implement this proof of concept, I just applied a retrieval augmented generation pattern. So this pattern is widely used in the GenAI use cases where you want the AI models to be able to answer the specific questions related to our own knowledge base. So I implement most of things in the Azure AI Studio, but to start, we need to upload all the PDFs to the blob storage or data lake. So once the documents are in the data lake, a batch job is triggered to parse the PDF document into plain text. And also we need to chunk those texts into small paragraphs. Then we use Azure AI, OpenAI embedding models to embed those small chunks into vectors, and we save those vectors in the Iris AI search vector index. So the whole ingestion process will take around 20 minutes to ingest all the 58 articles. So once we have the data ready in the AI search index, we move to the prompt flow. The prompt flow here works as a centralized orchestrator to handle all the communications. So when the user submit a request to the prompt flow, so in this case, going to be the name of a certain article. So the prompt flow will pass the article name as a query to the Azure AI search. The Azure AI search will return all the relevant information about this article. Then prompt flow will handle this article along with a system message with all the eligibility criteria in the prompt to the Azure OpenAI GPT-4 32K models. So it's 32K models means it's a lot of it's able to process a lot of information. And once the GPT-4 model process all the information, we will return the decision and along with the reason as a response to the prompt flow, and prompt flow will return the response to the user. From the user perspective, they don't need to understand everything behind in the background. So they just need to provide input and they expect output. Here, they just when they call it API endpoint, they just give the input as a name of the article, and when we run the endpoint, they just need to wait a few seconds, and the endpoint will be able to give some output with a decision if to include or exclude this article, along with the reason like which criteria is triggered to make that decision. Also with a full reply in natural language with a decision to exclude or include this article, the reason, and more background about this reason, then also the title of the article along with the source to the PDF file. So once we're able to process a single article, we'll be able to run this batch evaluation against all 58 articles in the collection. So for given article, if the AI decision align with the human provided decision, so we classify this AI response as correct. And if the AI disagrees with the human decision, we classify the response for this article as incorrect.
Do you know those decisions there? What part of, do you know in the diagram you showed before, which part are they coming from? Is it the very first part? Is it the ML job? So if you go back to the diagram.
No, the ML jobs is about how to ingest the data and save the data in the vector database. The decision comes from this response from prompt flow. So that's a response from AI. And the ground truth here is a response from the human. So that's the user provide the ground truth for us, and we can append to this table. We can compare the AI response and human response. Okay, during the first few days of the development, we managed to achieve a minimal variable product. Like our prompt flow achieved accuracy like 60%. This is not bad result at all. Still have room for improvement, but it definitely beat the random chance. And after that, we did several rounds of development iteration to improve the accuracy of our application by doing the prompt engineering and fine-tuning some parameters. Then after a week, we managed to achieve 80% of accuracy. So meaning out of the 58 articles, like only 10 articles, the AI got different decision as a human. So we just extract all those informations, and we provide those information back to the user, and wait another way for the user to give the feedback on the AI on AI responses. And until last week, we just heard from the user, and they mentioned there's actually some human errors in the result they submitted to us. So there are 5 use cases where AI gave the correct answer, but human actually made the wrong decision. So actually our accuracy should be around 90%. So that's very good. So now I've dived into some hands-on demos that will give you some idea of how things set up in the Azure AI Studio. So first, I'm going to walk through how the vector database are set up in the AI Studio. But here, when you want to create vector database, you just need to create index. So in the index creation page, you can just select the data source where you stored your source data. So here we store our data in the blob storage. So you can go to the container. Like in this folder, it contains a list of 4 articles, 58 articles. If you select this folder, and you can select the Azure AI Search Service where you want to create an index. And then you need to provide a connection to the Azure OpenAI to do the embedding. And if we submit this job, it will ingest all the PDF data and create index in the Azure AI Search. I'm going to do that, not going to do that because I already created the index already. So once we have this index ready, we can move to the chat playground. So in the chat playground, you can just use a GPT model and add your index to the model. So it's like plugging your own data set to the GPT model. Here I can use a better, oh, there's GPT-4o model already. So maybe you can ask a question about a certain article, like when was this article published? Then if you provide the name of the article, the GPT model should be able to answer a question related to this article. Yeah, the model says the article was published in 2021, which is definitely a correct answer because we can tell from the file name this article was published in 2021. So with this chat playground, you can only do some basic stuff and prototyping. So if you want to do more customization, you need to move to PromptFlow. So in the PromptFlow authoring page, so first you can see this visualized graph that shows the logic of your PromptFlow. So you have the input and output. So between the input and output, it's a series of actions that the flow follows to fulfill the certain business logic. You can do the vector index lookup, and you can run some Python code and also some prompt engineering code and more prompt node. So if you look into the code, so here we have input, can just be the name of the article, and also we have the output. So we expect 3 things from the PromptFlow application: the full reply in natural language, and the decision would be just a singular word to include or exclude this article, and also the reason is also a singular criteria. With criteria is triggered to make that decision. So firstly, we need to do the lookup to the vector index. So here just specify the vector index URL and your input your user questions. And here you can do the hybrid search, which means doing the vector and keyword search at the same time. And here we ask the model we ask the index to return top 20 most relevant information. That's basically all the information about this certain article. So if you look at the output, so you can see all the contacts are retrieved from our vector index, and it's going to return 20 output with the most relevant, and then we pass the retrieved information to this Python node. So what this Python node does is just flatten the JSON object into the plain text. So if you look into the output, you can see the input is what we got from what was returned from the vector index, and then the output is just the information in plain text. So then we move on to this prompt node. So in this prompt node is where we define our business logic. So we have a system message, very long system message, instruct the model to do a certain task. So at first we mentioned that your AI systems are designed to assist with systematic review. So, and we give a description of the study design. And here we will list all the criteria for inclusion. So you need to consider all those criteria, population, country, outcomes. And then we have another instruction, which we should ask the larger model to include all the articles that satisfy all the criteria mentioned above. And if there's any ambiguities, this article should be excluded. And after that, we also list all the inclusion criteria, and also we need to instruct a larger model. So any article that is unclear or doesn't fulfill the inclusion criteria must be excluded. Then we give the list of the evaluation of the article must be conducted in the following order. And finally, we enforce some formattings on the response. So it must begin with a singular decision to include or exclude, and then we ask model to explain why this article got included or excluded, and then they need to provide the full title of the article and also the citation to the source PDF files. And here is where we did most of the prompt engineering. So here we have 4 prompt variants. So as motto of our development work here, so I have a different version of the prompt, and that's just different text. And after this node, we have another large language node that's to extract the decision only from the above prompt node, and also another large language node to extract the reason only. That's the logic of this whole prompt flow. So in output, you should expect three output. The reason why the AI make that decision, a one-word decision, if to include or exclude article, and a full reply in natural language. Okay, so once we have that, we should able to evaluate this flow with batch information. So here you can use this built-in evaluation method. Here, because we are doing the retrieval augmented generation, we need to extract contact from the vector index. We use this question and answer with context feature, and we just need to specify which flow we want to evaluate against. And also we can run this batch scoring on all the variants of the prompt of your prompt engineering node. Then we can compare which variant works best in the evaluation. Then this page we can just append evaluation dataset. So that's a dataset provided user provided by user with the ground truth. So, so the data set will have a list of articles in the question column and all the decision from the user in the ground truth column. And in this page, we're able to pick the metrics we want to use to evaluate the model. So the groundedness means how the AI response align with the retrieved context from the vector database. Relevance means how the response is relevant to the answer to the question from the user. And the coherence, fluency is mainly around the language, if the language is fluent or coherent. And also we can compare the GPT similarity that basically use a GPT model to measure your prompt quality. So you can compare your prompt response with a user ground truth and see how similar those two sentences are. And also you can use iPhone code, which is basically calculate the accuracy between your response and the user provided ground truth. So here we need to do the column mapping. So for the context, we just use reply from the response, and the answer would be the decision. So yeah, I'm not going to submit the evaluation because it's doing the batch inferencing, which will consume a lot of tokens. That can be very expensive because we already done the evaluation. So we can just show you the result. Like in this evaluation page, yeah, we're able to compare two prompt variants. So I think the first prompt variant 2 has an accuracy of 88%, and another prompt variant that has a lower accuracy. So in this case, the variant 2 is likely to be pushed into the production. So once we're happy with the evaluation result, we can deploy the flow as a API endpoint. So here you can just use this deploy button. You can select the size of the virtual machine you want to deploy flow. And also you can configure the scalability of your endpoint. So when the flow is deployed at the API endpoint, you can go to the deployment tab. So from here, you should be able to find your prompt flow endpoint. And in this endpoint, you should be able to test your flow. So if I ask the same question about this article, submit to prompt flow. Just wait a few seconds, it should give you the response. Yeah, here you can see the response of the prompt flow. I provide a decision to exclude this article, and the reason because this article has a wrong publication type. So this is a not peer-reviewed article. It's a conference abstract. Also, it gives the full text in natural language to exclude the article and the reason, and also the title of the article and the reference to the PDF parse. So that's pretty much on the web portal. And the web portal is very good for prototyping and experimentation. But when you're into the development phase, you normally work in a local development environment. So if I open the Visual Studio Code, so we can install this prompt flow extension, then you have the exactly same development experience as a web portal. Apart from that, in prompt flow in Visual Studio Code, you can also do like single step debugging and version control. And also you can do batch run from your local environment. And to deploy the prompt flow from your local environment, you can build your prompt flow as a Docker image. And it just creates a folder with a Docker file. And with that, you can deploy to any like target cloud infrastructure you like. Okay, well, I think that's everything about this demo. Yeah. Cool. Yeah, that's all about my talk. So any questions?
Very good. Any questions?
Yeah. So do you know on the flows, how did you get between the prompts? Could you just go back a screen? I'll probably explain.
Yeah.
So do you know on the right hand side, each one of the flows, what I didn't get is how one would jump from one to the next one.
Yeah, in each node, maybe I just go back to the web portal.
Also, they're nodes.
Yeah, it's called node. So each activity is called a node. You can have
Yeah.
prompt node and Python node. So you just need to define the input in your node. So with the input, so you know which node it's linked to. Like here, you use input from the question. So the prompt will know the first node going to be this lookup because it uses input from the user input.
Into that variable.
Yeah. And after that, yeah, you can
So then
define
you just
output.
want to look up dot output to the next stage.
Yeah.
And then using that data again.
Yeah.
Right.
Yeah. And with this graph, it's just a YAML file. So if you look at the code folder, so this flow is just this YAML flow.
So what's the Ginger?
Ginger is your prompt engineering node. I'll show this.
Is that editable or is that just?
It's editable, yeah, but on the web portal, you need to toggle between the. Maybe I'll go back to Visual Studio Code. Yeah, that in this full folder. So this Ginger thing is just your prompt variants. So we are defining all your prompt message. Yeah, it's just plain text, and the flow itself is just this flow.dagger.yaml. So we already defined.
And that was the node boxes.
Yeah, that's
The
a node. The
YAML, yeah.
flow. Yeah, it's just defined in the YAML.
Yeah.
Yeah. Any more questions?
This is a vague question, but consultants generally have the job of going into a company and listening to what you do, and
Yeah.
learning,
That's right.
and they go away and analyze it all, and they come back and tell you the solution.
That's right. Yeah.
So this is like an automated version of that, really. You get all the distilled knowledge in files and put it in.
Yeah.
And then analyze it with a large language model, and then be able to ask it any questions.
Exactly. Yeah.
It's almost automated consultancy, I think, isn't it?
That's very true. And
Great one.
Am I
'cause
right?
I'm consultant as well. Yeah, because I'm consultant on AI. But the thing is, they need to hire a group of people like to read those articles.
Yeah.
I think that not really consulting. I think that's repetitive jobs. You just need to read all those papers, maybe 100 papers. You need to read all of them, and you make decisions based on what you read. But you can just throw all those papers to AI, and AI will read it for you and tell you what
But the
it is.
second part of the question is that if you have the software doing that job, you almost need a team of perfect experts to say why that is right or wrong, or could be better. So, and then it depends on that team of clever people who are judging whether the software is doing the right work.
Yeah.
You know, and if they're not quite perfect, then they'll say, yeah, that's okay. And, you know,
Yeah, I
it's
think.
difficult, isn't it?
Yeah, let's go to the topic of responsible AI, because for those things, we always suggest to have human in the loop, because you can't make sure the Gen app always produce the truthful information.
Yeah.
So like in this case, they need to hire 2 people to review the article. The plan is when we have this AI tool, they will replace one of the people with AI and still have 1 people monitoring the job from the AI. So that's the idea.
Those compared to Stack Overflow AI tools, might give you the answer, but you still need someone to sanity check it,
Yeah.
make sure that it's sensible.
Yeah, because the other thing is putting it, you can get an answer, but you have to put that answer in context and sort of just see how it lies with other interpretations. So interesting.
Thank you.
How do the tools work for just feel like what you speak about, sort of like the verification and like how is it doing that with the hook? Like how's it checking that code and giving you that score? So it gave you the score of like 80% accurate, right? But that's based on the results over time. What are sort of the mechanisms behind it that are actually saying this is right or wrong? Like the readiness test.
Yeah, because for this use case, we just compare a single word.
Oh, okay.
Because the result from the human is just 2 words, included or excluded. And we also ask the AI to give a single word response. Then we just able to compare those 2 words. If the same, it's correct. If it's different, that's incorrect. But in some real world use case, if the human response is like a whole sentence and the AI response is a whole sentence, it's impossible those whole sentence will be the same. So you can use the GPT model to compare the similarity between those 2 sentences and give a metric on that.
So I get where my question's coming from. So I'm building it's like a health thing for AI. So it's based on blood results. So it takes blood results from multiple people. And well, basically you build a profile on that person. So they'll have a blood result, say, every 6 months. And then over time, I'm comparing that data against the same data set that I'm comparing the results over time. So, I mean, this is something that's like based on, I guess, a doctor's word or like sort of what the country would deem, I don't know, between say 1 and 10, what they would deem like the correct result. So over time, it's analysing that data. But what I don't know is how to get to the stage of going, well, it is actually right, that data is like, what's gonna, I guess, what in the AI sort of tools, after I've written the application, could say, this is on the right track to be in the right boundaries, except for just saying, oh, okay, it's between 1 and 10. I'm trying to think of something to like sort of alert it and like sort of then start flagging up things to say, it looks a bit off or it looks like way off compared to the last result.
Well, I think that goes to the idea of how you evaluate your flow result. Because here, once you use your AI in the production layer, you wouldn't be able to know if AI makes correct decision or not.
Yeah,
It's predicting the future.
that's
But you need to do the comprehensive retrospective analysis on historical data to make sure on historical data, if the AI achieves 95%, is that statistical significance? You'll be confident and say, okay, we can use this in the production.
okay.
Yeah.
So it's just get more and more people.
Yeah, you need to do that. Yeah,
Just grow some confidence with them.
yeah, you need to do evaluation on the historical data. Yeah.
Thank you.
Just that, if you speak loudly.
Yeah, they were able to hear me from over here. Any more questions? I've got one. So you can do this all yourself, I guess. You can roll your own. We know this, rather than using prompt flow and all those bits. What is missing from what you've just shown that you would need to roll your own? Thinking how it goes about chunking and what control do you get?
What do you mean by roll your own?
So you can do all of this just with AI
Python
search and an Azure function.
Okay, yeah.
And just do that. Obviously, it's a lot harder than what Len's just shown.
Yeah, I think the idea of prompt flow is you make AI engineer life a lot easier. Yeah, it's an orchestrator. You can combine all different sort of resources into one.
Yeah.
Like workspace development area, and you can just manage all the connections to different resources. And also, this prompt varying thing is very helpful in like evaluation, prompt evaluation. And imagine if you want to do the prompt engineering in pure Python code, you just need to deal with those prompt as a plain text a string in
Mhm.
Python, and you just use normal like Git version control on those strings.
Yeah.
That wouldn't allow you to compare the performance between different versions of your prompt. But with PromptFlow, you can just do the batch scoring and compare.
So when you use your own services, you have to publish each one of those as an endpoint, right? And what you say, API management or something?
Well, not necessarily. You
Pull them
just,
all in, whatever you front end.
yeah, you could just use
Yeah.
environment variables and just go direct from an Azure function to say AI
Okay.
search
Yeah.
and ask it for the prompt that way. But the front end would have to
Yeah, you might
ask.
rely on front end to do the orchestration thing.
Yeah,
Yeah, but
exactly.
here you can more use front end as a static web app
Yeah.
and just submit one request to the PromptFlow orchestrator. It will handle everything for you.
What about the MLOps part? I was thinking more than anything, the chunking part, because sometimes it can be domain specific how you go about grabbing parts,
Yeah,
whereas you don't get that control, I don't think, with the MLOps side, do you?
yeah. I think you mean the embedding
Yeah.
part. Yeah, that part is especially a challenge. At the moment, the feature used by AI Studio is just use this Azure machine learning jobs to do the chunking embedding.
Yeah.
And it's just that's a very basic thing.
Hmm.
You just do the fixed size chunking and do the basic embedding. There's no OCR thing.
Yeah.
There's no like semantic chunking and other features.
Yeah.
Yeah, but I think in real world, if you want to improve the quality of your embedding, you need to use maybe document intelligence to do the OCR and infer the document structure. And also, you can use GPT-4 vision model to extract the text from a picture or image. So that will help the quality of the embedding.
Hmm.
Yeah.
There's all sorts of things you can do with embedding,
Mm.
not just grabbing a piece of text, but grabbing a piece before and end it to give it some context, or asking the model to actually give a meaning to that block of text and using that as some metadata and sliding windows for how you go about grabbing text, all sorts of different mechanisms. Yeah, yeah, exactly. And then all the metadata you can put around that as well, file names, who uploaded it, when it was uploaded. I guess that would be when, if you need that level of control, that's when you need to run your own, at
Yeah.
least the ingestion pipeline.
Yeah, I think at the moment the ingestion part is a decoupled process with a PromptFlow. So you need to like spend some upfront effort
Yeah.
to index your data.
Yeah.
Before you can use PromptFlow to query the vector database. Yeah, normally implement it as a batch job. Yeah, you can run it daily to embed your data. Yeah.
So if I'm using document intelligence at the moment, and I want that sort of data, like granularity, when it's uploaded, who uploaded it, I'd have to then import that into PromptFlow, doing what with the, because the import, it said, was it like URL storage account?
Mhm.
Are you talking about having to do it that way manually?
Yeah, you wouldn't, at that point, you wouldn't tell PromptFlow to ingest your data, which is what it's doing when you attach a storage to it.
Mhm.
You give PromptFlow the sources separately, I think. at that
Yeah,
point.
PromptFlow only connect to the vector database to retrieve information. Before PromptFlow, you need to do some job to ingest the data into the vector database.
But it will chunk your data and store it in AI search or whatever
Yeah.
for you, but it's that part that you could replace with something more intelligent.
Okay.
But the rest of the PromptFlow stuff and the connection to the search would
Yeah.
still remain. It's just how you get it into AI search. It is AI search it uses under the hood.
Yeah,
isn't it?
search, yeah.
Yeah.
And
Well, SQL
also,
Server's getting vector database now as well.
really,
So they announced it.
that could be a cool feature. Yeah, also with document intelligence, as you said, you can use this semantic chunking.
Mm.
Have you heard of that?
No.
So you can chunk the document based on semantic understanding rather than a fixed size chunking. So that's a really cool feature. Yeah, it will improve the quality of the indexing as well.
Any other questions?
Just one overall. So this is new to me, but is it sort of like in its infancy, or is it being used?
Mhm.
How far through its progression is it? This idea
So
of using software.
It's a
like-
relatively new service.
yeah, it's just become public,
Yeah.
generally available earlier this month. The AI Studio.
I was like, why have I not seen it?
Yeah,
you
we've
can
used
try-
it in production-like environments already. So it's pretty good.
And a
So
lot,
the PromptFlow part.
Would you
Yeah.
say AI Studio is like the best solution at the moment in Azure?
yeah, I think that's the Microsoft state of art. at the
Yeah.
moment. Yeah. and a lot of features still they mark as a preview. So yeah, you might expect some unreliability with those preview features. But generally, prompt flow is generally available, and chat with your own data is generally available. So you can confidently use those tools.
Cool.
Okay.
All right. If you want to stop sharing and then we'll try not to get loads of feedback. I'll come and speak up yours. It's going to be easier. Yep, and then on do your video as well. Okay. Okay, folks. Thank you very much for coming along. We'll be back on, theoretically anyway, on Monday 24th, back here and on Zoom. Thanks to BGSS, Rebel, PJG Creations and JetBrains for being our sponsors. And we'll catch you all soon. So thanks very much. And thanks for your help, Cole, as always.
Thanks very much.
All right.
See you later.
Bye-bye.